Hello everyone. We have a new lecture today in differential geometry. Let's take the covariant derivative. Covariant derivative. The covariant derivative is a tensor field of rank 1, 1. It's a tensor field del y. This is the nabla symbol to show that this is tensorial, to distinguish it from dy, d, say I, this is in sorry. For example, di yj, this is the normal partial differential equation, partial differential, not equation, sorry, term, which is equal to dyj over dxi. This is a scalar, but this one here is a vector, so the vector, in order to have an invariant derivative, which doesn't depend on the coordinates, we define the covariant derivative as follows. Del y on VW is defined as W del V of y. The covariant derivative of y in the direction of V. In the direction of V, this is the definition in a non-coordinate basis. Non-coordinate basis. We will elaborate on this more, where V, Y, and V belong to the vector field, TPM, tangent vector field, TPM, and W belongs to the dual vector space. So this is a dual vector, and these are vector fields. In a coordinate basis, now suppose we have coordinate basis di for the coordinate system xi. Coordinate system xi, where the vector y is written as yi di. What does that represent? This is a summation. This is the summation notation. This is contracted over I. So what is this? This is, suppose we have four-dimensional space, y0 d0 plus y1 d1 plus y2 d2 plus y3 d3. This is, say, the time component, y0, this is d0. Now we define d0. What is d0? This is d over dx0, which is d over d ct, time component. Similarly, d1 is d over dx1, which is d over dx, the classical x. d2 is d over dx2, which is d over dy. Also, finally, d3 is d over dx3, which is d over dz. So these are some definitions. Now let's go back to our definition of the covariant derivative when we have a coordinate system. Del y in a coordinate system is also y I semicolon j. We have j here, so we have dxj, downstairs, upstairs. Tensor product with di. This is downstairs, this is upstairs. This is the vector field, the basis of the vector field, di. This is the basis of the dual vector in a coordinate system. Now we have a coordinate system, xi. For the basis, di. The basis, our basis is di, d0, d1, as we explained already. Now, what is y I semicolon j? Let's see. We have already defined del y v w or omega say w. This is the directional derivative, generalization of the directional derivative definition. This is the directional derivative of y in the direction of the vector v. This is, we don't have coordinate system, the general definition. Now, we already defined, now we said take v, take y as, what is y now in the coordinate system? What is y? Y is, say y k, this is the scalar, the components, and the basis d dk. As we said, y0 dk d0 plus summing of 4 terms. We have y1 d1. What does it mean, d1? It means d over dx1 or d over dx. What is d over dx? This is the vector. This is the basis vector, like in the x direction. It will take you in the direction of x, d1, d2 in the direction of y, and so on. Now, what is v? V is what is v? Let us see what we have here. V is simply, let's call it d without any, just the basis vector dj. The coefficients are 1, dj, and comma. What is w? W is the dual vector. So the basis for the dual vector, we take the basis for the dual vector, not any other vector. We take dxj, say. So what do we have now? This thing is reduced to, let's write it properly now. This is del y, this is y, v, this is v, w, this is w. What is it equal to? It is equal to w, which is dxj, bracket. We said in the direction of v, in the direction of, where is v? In the y in the direction of v. This is v. dj of y. Should be clear now. So we moved from non-coordinate general definition to a particular coordinate system, which is the DI system, this basis system, with xi as the coordinate system. And we said the definition is reduced to w dxj del v. This is v. V is a basis. I can put any v. I can put vj, of course, vj, dj, and then I get the v. We will do it, and we did it, I think, maybe already some other time, some other place. Let's rewrite it. This is del dj. Now, let's go ahead and simplify, see where we arrive. So what is this? This is the covariant derivative. The covariant derivative this is, we said, equal to dxj. Get used to this one. Now we will apply Leibniz rule. We have 2 we have multiplication of 2 sorry, I should go here. So you do Leibniz rule, which is del j for yk. This is a function. It is a function which is the coefficient or a component of the vector in the dk direction. This is dk. Say this is y1 and d1. So this we will see that this times dk plus this is out now yk del dj dk close it bracket equal to dxj bracket. Now when you have here, this is del. Only when you have vector or covector, the del remains. Otherwise, when you have a function, with the functions, del is reduced to the normal partial differential derivative. Del goes to del. So this is it. dj. This is reduced to dj, which is d over dxj yk. That's it. We finish with this one. dk plus yk. Get used to this one. When you have this, the derivative of a basis vector, the derivative, this is covariant derivative of a basis vector. This one will give me a vector. The vector also, it lies in the same vector space. We have the same coordinate system. We have d, call it, for example, what shall we call it? dl, whatever, dl, gamma. When we have these two, del dj of dk, jk here, this is a Christoffel symbol, or the symbol, or the connection. It connects the connection coefficient jk. It depends on this direction and on the also the vector we have. So it depends on j and k, so we refer to j and k. And we contract over here, we take all the directions over all else, so we sum. Summing is you have repeated index. This is how, so you have no problem. You know the technique how to deal with the indices. How to deal with it is very easy, but you have to follow. You don't memorize, you have to follow it in a logical manner. So you see how we get this easy equation, apparently difficult, is very easy. So this is dxj bracket. What do we have here? We have k and k. Here we have dl, also ll. I have to make them the same to take out common factor. This is dummy index, L or K. So either you change it to L or K. We used to IJK. So we change this one to K. This one to K. Take the K out. So what do we have? We have DJYK plus, this is out. We have YK. This is, where did we get this K? No, we changed to L. We changed to L. And the K, we should change it. Well, we have many ways to approach it. It's good to mention. Let's go back. What is this mess? What is this mess? If I can manage this board, the problem in the board, I cannot get things clean, messy. How to move it? Let me practice here. Where is there is we made a mistake? Where is the mistake? It's obvious. When you make mistake with indices, it's very obvious. You have, for example, more than 2 in one term. Where were we? We were at this one. Let's move up and get back. Where were we? We have dxi. We said dxi. dyk dxj. dj. yk. dk. Plus, we have the yk. And we said del dj dk. That's it. Let's deal with this. We have 2 ways. Now it's good, I seen it. We have 2 ways to tackle this line. We either get dx to each one, and what do we have? dxi, this is dxi dxi dk. This thing is a Kronecker delta. Del ik, we had it in an earlier video that dx del, this is the dot product. This is the dot product. If this is I and I, it gives me 1. It gives me 1. Otherwise, it gives me 0. So what do we have? I and k. Also here. Also here. Same thing, dxi, del, also delta. So this gives me di yk del k I plus yk. We said this one was gamma j k l multiplied by what? By this one multiplied by, let's bring the dxi, and we said this is L, so we have dl, and these two, what will they give me? dxi dl, they should give also Kronecker delta I L. So what do I have now? I have the following. If I manage this board, I am in good shape. Equal to ik. So we put I, di, yi, di, yi. Let me see. Not di, dj. This is j, sorry. This is j. Where did I get this? I copied it wrong. dj. dj. We lost the battery. The pen needs to be charged. So now who can write? Short wire. The battery is charging. We have to pause now. Sorry everyone. You see the mess now. We practice till I get professional. It's only technical writing with the board and this pen, and how to write things in a proper manner. Let's take a break.